Finally live. Hello everyone, and it's our session 10 on the lead up to GCSE. This week, a direct and indirect proportion. Everybody knows how big proportion is. It's where something scales up in the same proportion by some scale factor, and that's because there's a special linear relationship. This is a concept, but today direct and indirect proportion is the formal way of writing proportion using equations. We take a look at the bottom here. I've got an excerpt from the specification which says that we must understand that x is inversely proportional to y, that is equivalent to x proportional to 1 over y. Construct and interpret equations that describe direct and inverse proportion. So we're going to be doing some of that today. There's 33 days to go, so countdown doesn't stop for anyone. As ever, if you want these questions before today, which I thoroughly recommend, go to Patreon. You got that little link there, patreon.com/tformula, and you'll find all of these resources to download ahead of time or use as you will. You know, there's a lot more there too. Please consider subscribing. It's free to just become a member, but let's get on with the questions. So, Kate's using a follow-in recipe that is designed to make 12 mini Victoria sponge cakes without using egg or butter. Erroneous. She must put them all in a bowl and mix them. So let me get the mouse here so we can scroll down. Sometimes this is useful if we did or did not know it. Okay, so big old list. She actually needs to make 138 of these cakes for a party. How much will the raw ingredients of 138 cakes weigh in total? Give your answer, oh dear, spelling, in kilograms. Okay. So in this question, we have to appreciate that we are, it's like it's a ratio question because we're scaling up. We don't want what we have, we want a multiple of what we have. The first job would be to find the scale factor, which scales it up. And hopefully you were thinking that in this case, we have to find a total which is 138 and divide it by how many we are doing it for. So for us, that's going to be 12. To find out how many times that goes in to the 138. Now I'm just thinking where I'm going to write this. Maybe I'll write it down here. So our first step is here, and our scale factor is 11.5. And obviously you can use a calculator, I don't mind. I don't know how you expected to do it. It would just be slower otherwise, but the concept's there fine. And it's strange, this question. Look, it says, what will they weigh in total? And then we look at the list and we have some milliliters anomaly. So it's got to be one every live stream, right? Minimum. So these milliliters, where do they come from? How much do they weigh? Well, it's a really beautiful relationship if the liquid is present in terms of milliliters. That 1,000 milliliters roughly translates to 1,000 grams. But this is slightly different for things like milk. It's slightly different for different viscosities. But when it comes to it, we're just going to make an assumption in this question that it's all purely watery and this relationship's hold. Therefore, we might want to convert some of these that are not immediately in terms of, hold on, let me adjust my microphone. Okay, didn't like that. Felt like I may have just broke my microphone. Okay. I'm just going to have to deal with this and cut it out of the video later. Hopefully it's still loud enough. Okay, I'll hold the microphone. You can never account for all problems in life. So, where were we? We want to convert some of these into weights because currently you can't add a total weight unless they're in terms. It's pretty straightforward. Millimeters go straight to grams. So here we have, we need to check out any, gosh, it's all messed up now. I've got my mouse somewhere else. All right, better. 175 mil, that's fine. That will go straight to this. And the last one, 30 grams. So we're going to have a total weight here. And I've done a little bit of the legwork earlier. So that actually comes to, when we add it all together, 1390 grams. So that's the total weight of what we have here. And our next stage is to sort of figure out what each of it's going to be, because we have a total of the ingredients and a scale factor of 11.5, meaning we need 11.5 times more. So 1390 multiplied by 11.5. I can't actually see my screen very well right now because I'm having to hold the microphone in my face. So bear with me. If I do something wrong, I'll have to rub it out. Where are we at? 11.5. Yeah, so this is 15,985. That's in grams. And then if we're going to convert that to kilograms, comes the second fact that 1,000 grams is a kilogram, so we're going to be dividing that. 15,985 divided by 1,000 is equal to 15.985 kilograms. And that depends how you want to round that, but we're just going to leave it like that. It's really not. There we go. Let's put it in properly as a dot. It's not that bad to do it accurately here. I mean, you could have wrote 16 to the nearest kilogram, but you're going to have to round that as you see fit. This is perfectly fine. And if you covered it, something similar, you probably got it right. Here's another option. You could have done to 2 decimal places. We'll leave it like this. Okay, so that's the first question. Pretty straightforward, and it's there for a good reason. This sort of question is a standard bread and butter sort of a question, like a flour and butter, but without the butter. And, you need to know how to scale things up. So the concept, and I think this is the key word, scale factor, that I'd like to put in there. Now, these are all very well. These relationships where it's a linear scale factor, just a straightforward multiplication. But we're going to be moving on to some more questions now that involve equations, like it said in the specification. So let's, without further ado, look at question 2. Given that h is of 1 over root j, complete the following table of values. So I went because this is kind of a language that we need to understand. This language is, it's like seen as alpha, but it means proportional to. It's like ringing. I'm going to write it down. Proportional to this symbol here. And when it is proportional to, this statement means that there is some value, like a scale factor, that will convert the left-hand side into the right-hand side. When it is 1 over, like this, this is indicative of an inverse relationship. So as one goes up, the other goes down. So how I would read this is h is inversely proportional to the square root of j. And that's how we write it. This is how we turn it into a formula. The proportional sign here essentially can be replaced with equals and a times k. And that seems really odd, but bear that in mind when I write it in equation form. So what I just described, h is proportional to the inverse of, is inversely proportional to root j, can be written as an equal sign, and it's k over root j. Now, if you ever wondered why, it's all the same when we do direct proportion as well, but it's essentially k times 1 over what was there. But we know that with fractions, you multiply the numerator, so that's why it goes on top, and you'll just get used to seeing it straight up there. All right, so this essentially is a formula with three unknowns. We've currently got h, k, and j, and it would be nice to just use h and j because they're the variables. K is a constant, and so to find that, we're going to need a value of h and j in order to get the k. And as you can see from the table, and yes, it was set up this way, we have one option or two options where we have a complete, you might call it a coordinate, or at least one part that relates to another, where we can put it in, because when j is 20, h is, we know the value of it. Let's change to the right pen. So what we can do is we can write that j equals, this is like showing you working out, h equals 4 root 5. Let's get my mouse down there so we get some space. And hopefully we could see that by putting this in, we're going to find the value of k. So k is equal to root 20 times 4 root 5, which is 1650 root 3 divided by is 40. So 160 times 3, yep. So 16 times 5, yep. So k is 40. This is information, and it allows us to complete our equation. So we're going to draw an arrow back here to remind us that this is the useful equation, and it's going to go back in there, which will lead to the usable equation, because there are only two unknowns. And this can be used now to convert h to j or j to h at any time. It's important, so it's going to go inside a box. Okay, good. Well drawn. So it asks us to complete the table, and using this equation is now possible. We see where we've got an unknown j and an unknown h. So I'm going to start with the unknown h, because the formula has already made h the subject. So 40 over root 1 is 40. So this value here is 40. Nice. And the second is where we want to find h. Sorry, do we want to find h? No, we want to find j. So it's just that the microphone is in my face. I can barely, the table gets cut in half. Okay, so we want to find j. Yes, we want to find j. So we'll put in what we know, root 800 equals 40 over root j. And there's a little trick here. When we have a number on the left-hand side and we have a fraction on the other side, we can switch out the denominator with the number on the left. Now, you can go through and prove that to yourself, but it's it can save a bit of time. So root j equals 40 over root 800, and therefore j is equal to the square of that. And j, with a little bit of handiwork beforehand, becomes a real nice number, 2. So you'll put that in your calculator, or you could figure out using roots here that you've got 40 squared over 800, and you could do the math there. That's going to be 1600 over 800. Anyway, so without a calculator, totally possible. And we've completed the table. So take a moment to realize what was key was being able to read the original reciprocal relationship, proportional to and inverse, then being able to turn it into an equation. First step was adding the k, using a paired coordinate to find k, and then using the formula to complete the rest of the table. It's a good question, but don't lose your nerve because sometimes it feels complicated at first. Okay, let's get on with the next one. This would be a modeling question. You open your exam and you've got a whole page to read. And it's not very nice. It's off-putting and it makes you feel like you're a bit lost. But maybe use a highlighter, and once you practice enough of the basic of this question, you'll realize what you're actually looking for. You realize that this first sentence up here is a lot like the first sentence from the previous, but there's more words. Here it says, given that h is proportional to 1 over, it's like a bit simpler. Here it says the number of secondary exam passes in a school's year group, blah, 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 varies directly. So varies is another word for is proportional to. And when it uses the word directly, it's not inverse, it's the opposite of inverse. So it's not 1 over, it's just straight up. And we'll see what that means in a second. With the square root of the number of teachers that have an undergraduate degree in the subject they teach, well, there's another problem. Where are the letters? We'll go back another page. And here it told us to use H and J. So after doing enough of these questions in the basic level, you probably start to want some letters to work with. And this is where you have to give letters if you haven't got them. Okay, so what would be sensible would be to use the letters P for passes. So let's get my mouse to the right screen. I've got 3 screens and I'm blind in one eye because of the microphone. Let's scroll up again. So it would be sensible to call the variable number of passes P and maybe T for the teachers, the number of teachers. And we're going to write that as a statement. So it says that P varies directly, which means it varies directly with the square root of the number of teachers. So that's the proportionality statement. And we could say when we're in the exam that where P equals the number of passes, T equals the teachers with undergrad. So this is just being clear, but I've kind of labeled it like at that point for this one. So what we need to do now is turn that into an equation. An equation is something with an equal sign. So I've already started this question and I haven't even got to the part where it asks me to do anything. So I'm going to turn it into an equation now because it's like inevitable. The proportional sign just changes into an equals, and then we multiply by k on that side. So this could be useful going forward. That's the relationship that they're describing between the number of passes and the number of teachers with undergraduate degrees in their subject. And then it says a school gets 2,400 passes in 1 year and 49 of its teachers have an undergraduate degree. This is data. In our previous question, we saw that we used this first one, 20 and 4 root 5. It was a fact that linked J and H together. And if we look over our page, this here is a fact that links P and T together. So P is 2,400 when, we should write when T equals 49. So this is useful for finding K. See how we're just answering this question and we haven't even got to the question yet. but it's good to know where it's leading. I only know that because it's very typical, right? We've got an equation, we've got 3 unknowns, we need to find k, so we need to be given a linked pair. 18 teachers without a degree in their subject are leaving at the end of the year, so that makes no difference to the number that have a degree. But if they're replaced with 8 that do, that means the total number will go up by 8. So first things first is to realize that what it's asking is to figure out 57 teachers, right? Because 49 plus the 8 is going to take that to 57. So there's now that's equal to t in this new scenario. How many passes can they expect if there are this many teachers? Well, we need to put that into a formula or an equation. We haven't got a formula or equation yet. We need to find it. That's a kind of an indicative move as to what we need to do. We kind of started that up here. So we're going to carry on with our work. Anomaly. Let me start again. P is equal to k root t. And then we found that P is lovely. P is 2,400 when T is 49. So this is using old data, but it's fine because no matter what you put in, it should hold if it's a good model. And we can it's like a regression. You can use this to predict other values. So putting it in, we've got 2,400 is equal to k multiplied by 7. So k, well, there's no way around this. It's not a very nice number. So we'll just leave it as 2,400 over 7, which leads us to the proper equation, which is 2,400 over 7. And we'll put it in brackets to keep it clear, multiplied by root t. It's important. We'll put it in a box. And we're going to go on and use this. So this is now fully functioning, where we can test out our actual question, where it says how many can they expect. You've got to think about this now as like a model that's going to predict. The input is t, so let's see what the passes. It's a bit easy to say population when you see the p there. The number of passes is going to be found by doing this. Not 49 this time, but 57. We should probably predict that it's going to go up. And if we put that into a calculator, we find that it becomes, we might have just enough space, 2588.5146. And we can round that to something sensible because we're not going to get half a person passing. You could argue that it's only a prediction, so it doesn't matter, and it's indicative of where it's going. So why not just round it up to the nearest whole person, and we'll make that 2,589 passes. Make that clear with the brackets there. And you've got to know that this is only a prediction. It's like a model. It varies. It's not an exact science. There's so many more variables here, but some people are saying, this is what they've noticed. So a very similar but larger school decides that it can model its results in the same way. There's a key there. It decides that it can, but we're not 100% sure it can. One of the reasons it can is that it's a very similar school. So when there are similarities, we could say conditions are fairly constant, and therefore maybe it's a good model. This year they had 4,600 passes at this new school. Or other school, should we say. If the school has 87 teachers with a degree in their teaching area, is there evidence that the model is suitable? What we're asking really is, if this is true, how many teachers does our model predict that we should have, and is that going to be the same as what they actually have? So we're going to use our equation again. This time I guess we can call it the number of passes with a subscript of 2, so it's different from the p that we wrote up the top of the page. And our equation will be the same because they're assuming that it works the same, except we'll have T2 to correlate with P2. And in this case, we're asked to test a hypothesis that we have P2 equal to 4,600 against the truth that there's 87 teachers. Something will be found tonight. 4,600 is equal to 2,400 over 7. That's not a 6. I'm sorry, let's change that. That's called writing too fast. All over the thing that we want to know is, like, how many teachers does the model predict that this school should have? They shouldn't have any business saying they should use the model if it comes out to being unreasonably different from how many they do have. Turns out that when we do a bit of rearranging, by that it's 4,600, should probably go into a bit more detail, divided by the factor of 2,400 over 7, and then we're going to square the whole thing, that T2 is equal to 180. Well, that's a letdown. This means that 180 teachers should have a degree in their area of expertise if the model predicts well. Unfortunately, I don't know if you've ever seen this before. You may have seen 180 is more than 87. But have you seen this? This means it's significantly more, like it's ridiculously more, if you will. Therefore, we probably want to write a little sentence. It's not a good model. Based on this 1 year anyway. I mean, it could be an outlier. It could be wishful thinking. But there's your evidence. Probably not. And I think we've justified it pretty well. Okay, so number 4. We're really flying through these. I love it. We don't want to waste too much time. I like to teach a little bit along the way because it helps if you're missing something. But it's also nice to get things done and be nice and concise, for sure. Where are we? We're at the top here. Okay, so this is the ultimate. This might be considered as hard as it gets. I mean, you jumped straight to the end, and it's a little bit strange. You could say, find the value of j when m is 27. Well, m is to do with this relationship, but you want to find j. Well, you'll notice that what links the two is h. So we've got that in both. So this could be useful. And when you see these, you know, like, how do I know when to do this whole method thing? It's when you see these two statements, directly proportional or inversely proportional to. Those things are like go signs, okay? So the first thing that you're going to realize is that you're going to get given a statement that you turn into an equation, and then you get given like a condition, we call it in more advanced, but you might call it a coordinate. It's just a pair of information that is in the relationship, so you can use it to find the constant. All right, I don't know how well you did on the pre-release questions, but here's the full solution on how to approach this. Let's get ourselves a little bit more. No, we can't really do more space. Let's start where we can. So if j is directly proportional to h, the first thing is to write the statement of proportionality. J is proportional, and when we say directly, it just means we don't write 1 over square root of h. And we have here that h is 64 when j is 72. It's going to be useful later, maybe not quite here. I have no depth of field, so sometimes I'm clicking in the wrong place. With one eye, you don't have depth of vision. The equation is where we replace the proportional sign with an equals, and we multiply by k, because that's the implication that j is related to this expression of h by one single multiplication that we need to find out what that is. And that constant can be found by substitution. So we've got 72 equals k times, and if you beg my pardon, if I can just quickly do the square root of h, there's 8. So here we find that k is equal to 9. And that goes into our original to give us a proper workable equation, which is 9 root h. As per tradition, we'll put that in a box. Nice. Okay, let's scroll down now because we need the second statement. Let's do it here. So h is inversely proportional. So we have to write proportional, but inversely just means 1 over what they say here. So m squared. There you have it. And our condition is m equals 60 when h equals 4. Again, I've jumped the gun. I should probably write this here because we need the equation. Let's section this off. H is equal to k over m squared, like so. And we're going to put that in to find out the value of k. So that's 4 is equal to k over m squared, which is 36. And actually, is this correct? Is it 6? No, it's not 6, it's 60. Actually, let's not be too... We can probably squeeze that in. 60, that's better. I was going to say, that's a very small number. There you go. So that's actually a little bit more awkward of a number. But if we do 4 times 60 squared, that's going to be 14,400. And that's the value of k. So we put that back into our equation. So we get a proper equation now. I'm going to write it underneath. H is equal to 14,400 all over m squared. Box time. Ta-da. Okay. Looking good, eh? So we've sorted that information. Sometimes I know it looks complicated, but sometimes there's only one thing you can do. When you see all these triggers like directly proportional to and all this sort of stuff, it's like a method kicks in. If you've done enough practice, it will kick in. And then we're left with something different than when we started. This was the question. This is where we are now. We seem to have 2 equations, and my golly, we can work with equations better than words. And we need to find the value of j when m is 27. So if we think about the logic of that, like we've got currently in these 2 equations a j, which is unknown, we've got an h, and we've got an m. And what would be really good is if we could have an equation that only had j and m. And in that regard, we need to eliminate h. So we need to eliminate h, like so. And how do we do that? Well, pretty straightforward actually in equation terms. We just need to make it the subject, and then we can equate the 2 things together. So what's best here? We've already got h as the subject here. Let's just rearrange this one over here. So we're going to divide both sides by 9, and then we're going to square. That's going to be j squared over 81 equals h. If you don't know about rearranging equations, I've got one coming up. I think it's the next one. It's got a bit of rearranging equations in. But yeah, check it out. Get that skill under your belt because that's important. We're here now with h equals j squared over 81. We also know that h is equal to 14,400 over m squared. Now we can bypass h now. Essentially, with a bit more space, they're all equal, so we could just pick these 2 to put equal, and hey presto, no more h. This actually becomes a lot easier when you don't have to fully explain what's happened. It's actually quite a quick method, so don't worry about that taking forever. And we're going to rearrange now. So my method here is, see, rearranging's coming back again. I'm going to multiply everything by 81, and just in case anyone doesn't know how to rearrange, I'll step by step. So multiplying the numerator for multiplying fractions, and then j, we're going to square root both sides, And then that becomes something rather large. 81 times 14, 400 over m squared. And we're going to just put that in a calculator. There's a way to work through this, but we'll put that in a calculator once we know, so we don't need to worry too much about that. Thing we're after is j, I think. Let's look at the question. Yeah, find j when m is 27. So there's our last one here. So we put that in as well. So the square root of 81 times, just like before. Don't be afraid to write the equation out again to include a new bit of information. It just makes things nice and neat. The only thing that stops you writing it again is patience. So learn to have that. You could do this without a calculator because I can see that some of this is going to cancel if you did prime factors. But it's not a bother if you don't. Figuring that out becomes quite nice. J is 40. So that's about as hard as I've seen. And what did that include? Some simultaneous equations. So that's coming up in the next live stream. We're going to do some simultaneous equations and some rearranging. But that's going to be tomorrow. So the way it is, everyone is a holiday, and I won't be here next weekend. So I decided to do 2 this weekend, and tomorrow will be the grand day. So it'll be a Sunday morning tonic, or as they might be becoming now, just tonics, because it could be evening or afternoon, who knows. And tomorrow that's going to be on a number of good things. So a quick look. Yeah, so tomorrow is going to be on, where do we go? Yeah, quadratic. I have to look at it because the list is there. So it's going to be quadratic sequences, simultaneous equations, quadratic kind, rearranging equations, and algebraic fractions, not one to be missed. They're also bread and butter, so be good to see you along there. And if you're watching because you're not live, you're just trying to figure out the answers, hello, and consider coming along if you have questions. But as ever, you can grab those from Patreon right now. In fact, they've been up for a whole day. I'll see you tomorrow night.